Login accepted.
Offensive security section of the academy schedule. So as I mentioned on Tuesday, we're going to be building into what we call SCARE, which is Swift's crack, attack, and root event. And that is going to be where over the course of this month, we're going to kind of teach you different offensive security techniques and procedures, and then you'll be able to put that all together at the end and kind of attack a network and do a report on it. And for this week, or for today, we're going to be going over web hacking and be giving you guys some practical experience with that. Just a reminder, we have the membership still open for $20 a semester, $35 a year. And that's for the alumni mentorship program. And for an introduction of myself again, I'm a second year computer science major and the co-director of Academy. I was on the 2023 NCAA team and current CPTC and CCDC. And for a table of contents of what we're going to be doing today is just giving you guys an overview of a specific attack and then talk about or give you guys a hands-on experience with that attack. And we'll kind of be going back and forth between that. But before we do all that, I kind of need to introduce you guys to Burp Suite because it's going to be the essential tool that we're going to be using today. And I sent out an announcement in Discord earlier, but if you haven't already, make sure to download Burp Suite kind of while I'm going through this. And I'll kind of try and explain how to use it and the essential properties of it. So I have a website open here, and well, actually, hold on. So if you downloaded Burp Suite on Mac, you kind of just launch it, or and you'll get this pop-up here. You really kind of just click through like everything default, just start up Burp. And then we have if you go to, so we're going to be using two main features of Burp, which is your proxy and your repeater. And inside your proxy, there's a few ways to set this up or use Burp, but normally I have a something called a proxy set up on my browser, so I can kind of proxy traffic back to me. However, you don't have to do this, and actually what I'm kind of having most of you do is just if you huh? I don't think I can actually. Okay. Yeah, if you open your browser, you can actually open something here called, like, it's a browser that automatically proxies back to your Burp, and you don't really have to set up anything. So for now, it'd be best to use this. However, the downside is that you'll have to kind of re-sign into everything. But I'll kind of give you an example of kind of what happens with Burp. And so with your intercept, basically you can capture any HTML request that you're sending out to any web server or kind of just the internet. And so all you have to do is turn on your intercept. And then when I like search something, I'll actually catch a request here. And I can see that I'm sending out to Google. And you can see what exact request you're sending. I'm sending a GET request with the kind of test as my search. And this actually won't go through until, like, you can see it just loading. It's waiting for me to kind of forward that through. And while it's waiting, I can actually modify certain things about this request so that when I go ahead and I want to forward it through, I can actually, like, although my original request was just test, I modified it to be test2, and then you can see now that like the actual request that I sent out and the response I get back is for the test2 query. It's kind of, you're going to be using that idea a lot in the following workshops, but that's kind of give you a brief idea of what the intercept can do. Now, you also have this thing called an HTTP history where I can see basically every request that I sent out. It can get pretty cluttered depending on like what you're doing. As you saw, like this was my original search here for test, but um, after I sent that request, I got a lot because I was like querying out to Google. So there's going to be a lot of like kind of filler requests that are made, and it sometimes gets hard to track, but it's a good place to kind of look back on everything you've made in case maybe you sent a query out that you want to look back on and use again. Now, from either the proxy or your HTTP history, you can also use something called the repeater. So if I'm hovering over my request here and I just either right click and I can send to repeater, or I can press the shortcut listed there, which is going to be Command R on MacBooks and Control R for everything else. If I send this to the repeater, I can get my request and I can see a response in a send tab. And basically what this allows me to do is um, instead of like um, instead of having to constantly intercept requests every time I want to kind of test a new payload or a new like search, I can do everything from this repeater, and I can modify the request like as needed and kind of see how the website would respond to that. Um, Now this is going to look, it's kind of hard because I'm searching on Google, like I'm getting a lot of responses, but like if I do use something um, like on this website, okay, uh, yeah, the website kind of died. I think the website's been open a bit too long. But if I take like an example from one of the practices here, it'll kind of be a bit more clean when you're looking at um just the website, not like searching on Google, because that's when it can get really kind of complex. And I'll give just like a last example here of something before I kind of move on. But if I turn on if I capture a request in burp, um, because this is like on just like a kind of an isolated website, I can kind of see it's a lot less of I'm getting a lot less like clutter. And if I send this to my repeater and I'm kind of like testing different queries, like you can understand this response a lot better than the Google one. And uh, this is what you're going to be using, so you kind of don't have to worry about any of that. And um, mostly you're going to be using burp to kind of mess around with like something like this search here. Um, I can see that I'm passing in some sort of query or like query into my search request. And with burp, it allows me to really easily test different payloads or different like special characters that might cause errors or get me kind of unauthorized access to certain data that I wouldn't normally have. And so kind of with that explanation, we're going to be moving into the practical hands-on experiment of this workshop. I'm not quite sure. Oh, I'm still proxying my traffic right now. Okay. So with that, we're going to be getting into our first attack here, which is command injection. And there will be a couple of labs tied to this. But before we get into that, I wanted to give a quick review of like what even command injection is and what you should be testing for when you're on websites like these. So command injection is a way that an attacker can execute some sort of command on the server-side system. And this occurs because the server is just passing in like different, or it's passing in user input without correctly sanitizing it, and it's passing it into some sort of OS execution. So in the example here, we can see that I'm making a request to purchase PHP, and I'm passing in two parameters with the owner ID and the recipient ID, and then it's taking those two user inputs and passing it through this shell execution. And because of that, we can actually exploit this by adding um, we can add a semicolon, which will close out of our statement, and then we can add our own command at the end that we want to execute. So what this will look like is in a burp request, that something like the one we captured before, we can see our user input that is passed here at the bottom, and we can append a semicolon and our statement that we want to execute, which is ping. So once we send this through, it'll it'll get registered on the server side as the bottom statement, which is going to cause it to run a ping command. Now, with that, it's time for you to kind of try this yourselves. I have put together a collection of web hacking labs, and I want you guys to kind of go through the command injection first. There's two challenges for the command injection, and we'll be going over them in approximately 20 minutes, or like around 20 minutes, kind of see how long it takes for people to get through it or start getting through at least the first one. And then we'll review it and kind of move on to the following attacks. And you'll find the collection of these labs and the whole briefing packet here at the link. I'd recommend just looking up the link on your laptop because you'll need to access the websites there. However, I did put the QR code in case you want to read it on your phone, although I think the formatting is a little messed up, so I wouldn't recommend that. And feel free to reach out if you have any questions. I'll try and walk around and see if anyone needs help. Also, if you want to access the slides kind of for reference, the slides are posted on our link tree, and I'll get the link in the slides here too. And just as a notice, someone just pointed out, but I had an option on here to kind of clone a web hacking um, Camino pod, but it's broken right now, so you're gonna have to just download Burp yourself, or unless you have like your own Kali, just as a kind of PSA. All right, all right. So um, it's time for some other review since it's been around 20 minutes. I'll be going over kind of how to do the command injection for anyone who hasn't. Kind of explain um I guess more of like how I use Burp and how I went about it. So if we go visit the website that it gives us, we kind of so when we visit the website, we can see kind of a um you can see a shop, and if we look at any of like the items here, we can actually see a check stock option at the bottom. Now, this check stock is kind of alarming because it means that, or it's an option that can be sending some sort of request on the back end. And so that's what this kind of lab wants to abuse, is that it's trying to abuse this request. So I'm going to be using a proxy for this, but know that it works the same way on your browser. And if I go into my proxy here and I turn on my intercept, then when I run the check stock, I'll get this HTTP request here, and I can see a product ID and a store ID. Now, this should look familiar to kind of the example we had here, where um, we can see that we added like a ping at the end. So, and if we look at our briefing packet, we're supposed to execute this who am I command. So kind of what I'm going to do here is just append on the semicolon here to finish off the statement, and then we'll run the who am I command. All these other this other stuff is because I'm on like my default browser, and I have like Google open, so it's kind of leading to a bunch of requests getting caught. But if I go back to the website, I can actually see that it outputted my username here. It's a little messed up because I think it's getting, yeah, it's getting like combined with the units, but it outputted the username, and that's it gives us the congratulations that we solved the lab. There's a bonus challenge here as well, which asks us to cause a 10-second delay. And this 10-second delay, it's going to be actually using the kind of example we have here. So what ping is a command that will repeatedly check the connection of another computer, and you can actually specify a count, which is with this taxi, and then you can specify the IP. But we can also ping our local host. So if I go in here, oh yeah, on this one we can actually see there's a new button here, which is submit feedback. And let me go ahead and fill it out a bit. And now if I turn my intercept on again and I submit the feedback, we can see our parameters here, which is the bruh and the email. Normally you would have to go through and test kind of all of these different parameters here to kind of see like, oh, which one is going to give me like a delayed response, right? But actually what we can do, or so what you would do is that you'd tack on this ping and then taxi on your 120 on your local host, so that this would run, like you're basically trying to run this on, you're trying to make it run like a ping command on itself for 10 seconds. And you have to specify 10 on the count. But this would make it run like a request on itself for 10 seconds. And after this, you also have to URL encode your message because you're making a URL request. So on burp, you can do that kind of by just pressing Command or Control U. And we get this request here that I'm going to kind of copy and paste on every single subject. Okay. I think I messed up. Did I mess up? Yeah, how do I? Did it change it? Did it? I don't think it. Is that easier to read in the back? A little. I don't think it actually. I think it changed everything except the actual request itself. Um, I don't think this is working anyway, so I'm not sure. Hold on. Let me do some testing. All right, so yeah, with this this solution here had a bit of a weird case where like um the way you would execute or kind of escape your original parameter, instead of having um the semicolon as we had before, we'd be using these double pipes, and it kind of isolates the command. But the general idea is that you'd still be appending it to the end, and there's kind of a lot of, in like command injection or a lot of web, you kind of have to do a lot of workarounds. As you kind of go further into these labs, you might see that with the harder questions. However, the easy ones should kind of stay um, relatively similar to the slides. But as you can see with this kind of request, when we send it through, what we're looking for is that our response doesn't come for 10 seconds. So it kind of just hangs. And that's something that allows it so that you can actually see like our response, it doesn't contain any text. Whereas like the one before, it contained the username. And so there's a lot of cases where your website might not be providing you feedback. It might not be returning the command you ran, but it's still running the command on the back end. And running ping is an easy way to check like, is it running on the back end, but I can't see it? And so that's kind of what this lab was meant to do. And let me turn off burp now so I can come back in. And now we'll be moving on to the SQL injection. So SQL injection is, it's kind of similar in a sense that you're going to be appending a to like a normal query or a normal request, you're going to be appending some sort of additional information or data. So if we kind of look at like a normal SQL query, we can see that we're just searching for Apple, and on the back end, we're doing some select and getting our data from the listing and returning anything that has Apple in it. Now, if we can go ahead and append some information like before, we can append this little bit at the end to our query, which will create it so that the server will basically return all our items. Like it'll return all the items instead of just the ones that it's supposed to search for. And if we kind of look at the request a bit, the comma or the quote and the parentheses kind of fills in that search query. So you kind of exit out of that original statement, and you have a or parameter, which evaluates, combined with the 1 equals 1, will evaluate to always true, which means that this original search for the listing doesn't matter because your second or parameter is always true. So it's just going to return basically everything from that search or that database there. And the last part is that you're going to comment out with the two dashes will comment out anything in SQL language. So commenting out the rest of the statement allows you to not worry about any of the additional parameters or information that might have been added to this statement that might prevent it from running how you want it to. And with that, we have a couple more SQL labs listed on the docs, and we'll be going over those uh, probably in 20 minutes. Again, if I can keep track of time. Hello. So, it's been around 20 minutes, and I'll be going over the um the SQL injection attack now. I'll be going over the first two. So, um, there was two challenges here and a hard challenge, but I'm gonna leave the hard challenge for kind of if you guys want to do it later on. So, the first SQL injection attack takes us to this website, and it asked us to find some of the hidden products on the website. I'm also gonna go ahead and close out some of my tabs just to make it simpler. So when we get to this website, we can see just it looks like before, the same as before, except now we have some sort of a search query. We have a few like I can sort by like corporate gifts, gifts, pets, and this indicates that we're probably making some sort of modification our to our backend or make some call to our backend API or our backend database here. And what we can also see is if we look at the URL here, we can see that we're making some sort of search on like if I search gifts, I can see category gifts. So what I can do with this is that I can actually just append. If we look at our slides from before, we can see that we're appending like this statement here. And if I take that to kind of exit out of my commands, and then run the or 1 = 1 and comment everything else out, I can uh I can get everything here. So we have like our single food, our 3D voice assistants, like these are all things that were hidden. And we also get our congratulations here. And there's also another way to solve this, which is you can kind of make your request through burp as well. So with burp, if I kind of wait, with burp, if I have my search for a gifts, right? Um, I can kind of see the same request here where I'm making a search for category gifts. Um, burp is basically showing me the same. However, it kind of formats your URL a bit differently. So instead of having the entire URL in one spot, and then I append my attack to the bottom or to the end, I have my directory listing here, and on my URL, the rest of my normal URL listed on my host. But I'd basically do the same attack where I just add on a 1 = 1 and send this through, and I get the same gifts listing of all the hidden objects. Now there's also the follow-up challenge here, which tasks us to sign into the administrator account. This is going to be using the same sort of kind of bypass on your SQL, but it's going to be bypassing an authentication. So when a lot of sites use a SQL command to basically check whether your username matches up with the password in the database. And what we're going to be doing is trying to um, add on this additional true statement again, so that even if our passwords and username doesn't match, that will still be authenticated because the 1 = 1 is true. So um, when we go here, we're going to see similar website again, but we have a my account page. And what do we see is a username and password sign in. So if I type in my administrator name, you can kind of see well, the attack here. There's a few, well, I guess I should have mentioned, but there's also, you can also kind of, there's a few ways where you can do either the 1 = 1, and kind of always verify yourself as true, or I can just comment out the rest of the SQL statement. So, like let's say uh, let me make sure this works first. Yeah. So, basically like if my SQL statement was saying for like check query the administrator and then check whether that matches a password. If I just query the administrator and then I comment everything else out, then it's still going to authenticate me because it doesn't run the second check part. However, this does, I'm pretty sure this works with the or 1 = 1 still. And yeah, so I still authenticate as administrator because I'm still like the logic is still there where it's always true. And it's still commenting out any of the kind of verifications afterwards. Now we're going to be moving on to the path traversal here, which should be more of a relatively easy vulnerability. Um, path traversal, well, actually, I think it was a bit complex, actually, I think, but you guys will do fine. Um, so the path traversal is where the vulnerability occurs when like a website is trying to insecurely load a file on their local system, and they're trying to basically like read from it. So if we have we have like a PNG file that we're not even verifying, we're kind of just loading in. Like I'm just saying, oh, load this, and that's in my path. Then what you can do is actually I can go ahead and append, kind of escape out of the original home directory and go find additional files around the file system that I shouldn't be able to access. So if we look at the original uh, request here, we have the file search, and then what was supposed to be a .png file, we can just escape out of with uh, two dots, which is going to back up a directory. Or it's going to move you up a directory in the Linux file system. So if I do this a bunch of times and then get to the root directory, I can kind of choose where to go. So I can choose to go to /etc password and then just uh, like read what's in there, even though I shouldn't have access to that. Um, I think I do. I'll give like kind of a hint on this third attack here. It has to do with it's going to be a similar way to kind of the slides, but you should make sure to look at kind of how the website is loading the files. Um, so let me look. So like around the website, it may not look like much, but think of like what's getting loaded. Um, I'm pretty sure the files are getting loaded somehow. So if you can kind of figure out how to check the backend code or check the code on the website, kind of think of where images are loaded from and see if that kind of help you manipulate your requests. Uh, all right, I'm gonna give everyone kind of working on this a bit of a hint. Uh, I'm gonna kind of tell so like when we're trying to abuse some path traversals, we need to figure out like um something that's actually loading like loading some sort of file itself, right? And kind of looking around the website, it's hard to tell what's doing that, but I mean there is one thing that's loading. That's our images. They're always loading here. So kind of if we take a look at our client-sided HTML, we can see. I don't know if is that hard to see back there. Uh, we can kind of see this image source, and we can see the image is getting sourced from this kind of directory here /image. Use that as you will. All right, so we're kind of running low on time, so I'm gonna try and go through this one relatively fast and then kind of move on to our fourth attack. Um, with this attack, you're asked to access the Etsy password file here, and as I showed before, uh, when we look at kind of our images that are loaded on this site, we can see this end page here with the or like this directory, which is our slash image, and this slash image is loading the file. It's loading the image, right? So what we can kind of do is if I send um if I send a request to burp, right? Um if I send this request, I can add on kind of where I want to access. So I want to access, let me send this to repeater. Um I want to access the image directory because that's what's going to allow me to search for a file. And then within this directory, which is that's kind of the hard part, is to find this endpoint. I can actually kind of, when I go back and look at the slides, we have this like Etsy, we're escaping out and we're going to go to Etsy password. So if I try and do that um, on this, I forget if I might need to have the image here. So let me see if this works. Yeah, I need oh, parameter file name. So, oh yeah, so we have this, right? The file name is 55.jpg. So forgot to add that in, but we have the file name, and then so we're looking at the image endpoint, and we get to search by file name, and then that's when we can append the local file that we want to hit, which in this case is the Etsy password. And when I send this through, I can kind of just view. It outputs everything in the response here. The reason I put this um, in burp here is because it kind of works a little weird with if you do it straight in your browser, it'll kind of act up on you because I think it's trying to load an image specifically. So like you'll get kind of just this, uh, but it is responding to you with the right answers, and you can view that just by looking at it. The response is actually giving you in Burp Suite. So this response window is just kind of what you get when you're sending requests specifically through Burp. So you can, I mean, you'll see it in like, or it's visible in repeater because the proxy is going to load to your actual your browser. So like when I send a forward request through like when I intercept a request on Burp, and like when I send this request to Burp and I forward it through, I don't see the response because it's sending it straight to my browser. However, when I do something um like when I send it to my repeater, that's where I can actually see like my exact request and the response I'm getting from that request. So it is kind of nice to kind of experiment with, specifically in the repeater, and it works really well for kind of these kind of purposes. Since we're running low on time, I'm going to just cover this last. We have one more. Uh, we have one more, or two more vulnerabilities, but I'll only be able to cover one, and that's going to be cross-site scripting. Um, this is an attack that uses custom JavaScript. Or it's able to execute custom JavaScript code onto victims' computers, and there's both a stored version and a reflected version. So your stored version is where you can upload something to a website, and then every time a user loads that website, the malicious JavaScript code will also load, and then that will be able to send you data from them. So that includes cookies, and like XSS usually targets cookies. However, in this hands-on, you'll be just sending alerts, because when you send alerts, it's just a way to prove that XSS exists, and then you can do other things with that. Now, reflected is when you kind of just you modify your URL and do the same thing and expose like execute the JavaScript, but you're executing it through the URL and it only works one time. Um, I have an exploitation here for XSS, but this isn't really um, relevant to this hands-on because this is assuming that you want to send your request to an attacker computer. However, in this case, we're just trying to alert onto our own computer. So um, just kind of the payloads you'd be kind of aiming for. Like there's a lot of different payloads out there, but there's a simple one I'm trying to find. But you can kind of look up like different payloads that you'd want to fit in to where um, into different attacks. And if you kind of look up like uh, actually on all these issues, if you are kind of confused at what's happening, you can look up on Portswigger as well. It's a great place to just show go really in depth with each vulnerability, tell you kind of how to test for everything. I think they might. Yeah. So yeah, in here, I'll kind of put this in here for you guys, but this is like a very basic XSS payload that would alert for basically it just alerts it would cause the alert to pop up on your screen. So try and I guess knowing this is the payload, try and get it to execute on your on the websites you have. Just get it to execute this alert, figure out kind of where to put it. And yeah, I know there's not much time, so I'll be going over this in like 10 minutes, just really quick. And then there's one last one, which is SSRF or server-side request forgery. That's gonna kind of have to be left to another day or kind of on your own. But the slides will be there, and they kind of walk through how to kind of approach that type of attack if you're interested in it. So kind of finishing up the workshop here, I'm gonna be walking through XSS. Um, this alert here is kind of what you need to do to use in this case, and let's go ahead and just navigate over to the website. So there were two challenges, one for stored and one for reflected XSS. They're both gonna do pretty much, well, they're doing the same thing. They're gonna send you an alert, but in different ways. So starting with the stored XSS, we can see we have like a blog website. And if we look at like one of these posts, we can actually see that there's a comment section. What this kind of allows us to do is just we can add our JavaScript to the comments, and that's going to be stored because it's something that the server is going to keep on their backend. They're going to keep in their data, and it'll constantly be loaded whenever a user tries to view that post or view that comment. So if I'm pretty sure it's in the comments here, but I'll put in my name anyway, and then we'll do a website. Well, actually, I don't think we need a website here. So I'll just kind of throwing it both in here. If I post the comment, I'll get the congratulations, but to kind of as a proof of concept, when I go back to the main page, I'll get this alert. I'll just get one. That's because it's loading, right? When I load this blog post, I'll see this script here, and this is what's actually triggering. Whenever I load this page, I'm gonna get this, and whenever any user loads this page, they're gonna get this XSS alert. That's very dangerous and can lead into just like um that will lead into like the cookie stealing that we've talked about on Tuesday, being able to redirect that information or get the data out of that JavaScript. Now, with reflected XSS, this has to do with your searches and your queries and your URLs mainly. So what we can see here is we have a blog, but we actually have a search, right? When we search normally, we get this parameter up here. So kind of what happens if we just throw in, I think just we can throw in our script here. And yeah, we'll just get an alert. It's gonna render on the server side and or the client side at least whenever this URL gets sent. We can see it appended at the end here. Um, and this is gonna be where like kind of with the phishing links or like this isn't gonna be as dangerous because it's not everyone who loads the page is gonna get hit with the XSS, but it will be anyone who clicks on this link will, every time they load the link, they're gonna get that XSS alert. And that's kind of keep in mind that this is all very this has no like defense mechanisms in play. It's all very, very vulnerable and very kind of supposed to be very basic. So as you kind of go further, if you decide to dive into this, the more web vulnerabilities, you'll get into kind of like how can if let's say like um the website decides to block kind of like these like what if it blocks anything that like has these greater than or less than signs, like how can I bypass that? And there's a lot of different ways, but it gets kind of very confusing, and you'll start using a lot of different special characters, but um it can get very interesting. And that's gonna mostly wrap up our presentation today. um we have there's one last request and one more request on the or one more attack on the briefing packet. We don't have enough time to cover it really. That's with server-side request forgery, where you're able to basically manipulate the server to uh, access internal pages that you're not supposed to, like an internal admin panel or an internal like GitHub website. Um, this does exist on the workshop or the briefing packet workshop if you want to take a look after the after this workshop at home. And also, if you do take a look at this, outside of um, outside of the workshop, you can actually here you can actually each of these labs they have a solution attached to them. So if you're kind of interested in that, just go ahead and whenever you load up a lab, you can actually click this back to lab description. It'll kind of give you an overview, and you have both the actual solution here and kind of community solutions with like videos on describing it if you're kind of confused on what's really happening there. Um, and yeah, thank you guys all for coming. I hope you enjoyed the workshop and you learned a lot here.